Okay, let's start, guys. So yesterday we have seen type 1, type 2 error. Okay, but before that, what we have seen, one way of accepting or rejecting null hypothesis, or simply we can say hypothesis testing. Fine. So now, actually, if you see hypothesis testing is can be done in two ways, guys. Okay, can be done in actually in two ways. One is rejection region approach. Okay. Second thing is p-value. Okay. Second thing is p-value approach. Okay. So first is rejection region approach. Second thing is a p-value approach. So we have seen the rejection region approach. Fine. So what was the steps we have followed? So these are the steps we have followed for the rejection region. So what is the main point in rejection region? We will find out a region. Okay, we will find out a region where we can reject the null hypothesis. How? We'll calculate a critical point. Okay, 1.65. How did we get this 1.65? From the alpha is 0.05. Fine, 5% area, like that we have calculated 1.65. And then you'll also calculate test statistic. Okay, whatever you're calculating from the test parameters, right? So these are all test parameters, 50, 30. From that, whatever the value you are going to get, that's called test statistic. Okay, so that value you will find it, and when you compare the critical point and this point, if it is falling in the rejection region, you will reject the null hypothesis. Is that true, guys? This is what we have done, right? Right. So now there's one more approach called as p-value. Okay, but before going to p-value, we need to understand why we are not using this in every case. Okay, if this approach is very good or good enough, why we should have one more approach? Obviously, right? So here there are actually two major problems with. Okay, there are two major problems with rejection region. Okay, see, the one main problem over here is we are having some issues here. One major problem here is, see this. Okay, let's say this is, in above example, this is 1.65. Okay, what is this? This is rejection region. Okay, and our z score is somewhere over here, 3 point some 4, for example. What was that? 28. Okay, 3.28. Fine. So here because 3.28 is falling in this region, we have rejected. Agree? And now there are 2 points here, guys. The problem here is, the first problem here is, if critical value is 1.6, right? So critical value is 1.6. Okay, critical value is 1.6. So this is test statistic. Okay, even though the test statistic is just 1.7, okay, even though test statistics is just 1.7, still we are rejecting. Okay, even test statistics is 1.7, fine, still we are rejecting. But how much correct is that, we need to check, because even if it is slightly greater than 1.65 also, guys, try to understand that we are considering that it is falling in the rejection region, and we are saying, hey, we will reject it. Okay, but is that practically like efficient? Because with the very small minute values, if you are completely rejecting the null hypothesis and accepting an alternate, it will obviously change many things, because rejecting hypothesis is one thing, and rejecting is one thing, and exactly opposite is accepting, right? And if that decision we are taking with very small minute values, obviously it's going to impact many things, right? If it is 3.28, that's fine, because if our critical value is 1.65 and our test statistics is 3.28, there is so much gap between that. So obviously we are confident enough that in this case we are going to definitely reject it. But if it is just 1.7, or if it is just 1.69, something like that, still if we are going by the theorem and we are rejecting, right? So we need to answer how much it is correct. Okay, but second important thing is, let's say we are having 1.7. Okay, let's say we are having 3.8. Okay, let's say if the statistic, if there is one more test statistic, how did we get this 3.28? Yeah, this is a formula 3.28. Agree? So for example, if you see, when this value will, what is the relationship between, can someone tell me what is the relationship between this n, what is n over here, number of samples, and this is a test statistic. What is the relationship between this n and this output value, guys? I mean, like if n increases, the test statistic increase or decreases?
Increase.
Increases. Let me see. If n increases, the square root of n increases. If this increases, this whole thing decreases. If whole thing decreases, this will increase. Okay, so if n increases, this also increases. Fine. So if you have considered, okay, if you took sufficiently large amount of samples, okay, in place of 30, let's say you have took 300 samples, okay, and let's say from 3 it went to 30. Okay, so in another example, you are having something called as, sorry, okay, here you have assumed 30. Okay, now what we'll do, we reject all 1.7 also. Okay, just, okay, 1.7 also, 3.28 also, and 30 also. Okay, just give me a second, guys. This is giving me, let's see, did I, Okay, sorry guys. Okay, so now going back. Now the point here is we are rejecting 1.7 value also, 3.28 also, 30 also we are rejecting. Agree? So, but what is the strength of rejection? What is a strength of rejection? Okay, because you cannot reject everything with the same confidence or same strength, right? If it is 30, you should be more confident, and if it is 1.7, you should be less confident. Agree? So, because of these two major issues, we have something called as p value, guys. We have something called as p value. Okay. So, as I said in SS class, p-value is the most important concept, okay, in the hypothesis testing part or in the statistics part you can consider. Okay. So, we'll try to understand what does a p-value mean. Okay. So, there are like, you will find many definitions regarding the p-value, guys. Okay. So, often people will try to confuse you with different definition statements about the p-value. Okay. But fundamentally you need to remember p-value is okay, p-value is nothing but okay. See guys, p-value is nothing but it is the, see guys, probability of okay null hypothesis being true. Okay, probability of null hypothesis being true. Okay, so p-value single line definition, you can take it as probability of null hypothesis being true. Okay, so that is what p-value is. And what does this, what we'll try to like how it is, what it is trying to tell us, we will see. But you can just think p-value is nothing but it is the probability of null hypothesis. Okay, as I said, we will always focus on the null hypothesis itself. Okay, we will never talk about the alternate, because working on null is automatically equal to working on alternate. Agree? So that's why p-value is what, that one value which will tell you the probability of null hypothesis being true. Okay, fine. So now there are like multiple interpretations of p-value, guys. Okay, so you need to like understand p-value in I would say multiple angles. Okay, so that it is more easy for us to understand and recollect it faster. Okay, so what are those, we'll try to see. Okay, so let me just see if I can push this. Okay, anyways, fine. So see guys, guys, just stay here. I'm pausing your video for a second. One second. Okay, so now, yeah, let's try to understand the actually the p-value, the meaning of the p-value is. So p-value e, before that, see, I will summarize two things. We have seen what we have seen is alpha. Okay, alpha is what the probability of null hypothesis when it is actually true. Okay, probability of rejecting the true null hypothesis. Okay, so let me write it those two values. Okay, so actually this will be very very important. Okay, see, you have mainly two things. Okay, one is p value. Okay, and before that, what we have studied, guys, we have studied alpha. Okay, now alpha is also what, can you see a significance level is also called as alpha, is also critical region. Okay, but fundamentally what is this? It is the probability of null hypothesis being true. Okay, it is a probability of null hypothesis being true. Fine, but oh, did I say, oh sorry, it's no, it's not that, it's a p value. Okay, significance level is what, probability of rejecting a true null hypothesis. Okay, probability of rejecting the true null hypothesis. Okay, and probability of null hypothesis being true. Okay, see, these two are, see guys, alpha is the significance level is probability of rejecting a true null hypothesis. Okay, that means what, null hypothesis is already true, but what is the probability of you rejecting it? That means uh, not accepting it. That means considering some mistake. Okay, committing some mistake. Getting, so probability of rejecting a true null hypothesis, that is alpha. Okay, but p value is first of all, what is the probability of null hypothesis being true? Okay, what is the probability of null hypothesis being true is called as p value. Okay, fine. So if you just step back, see, there is one more interpretation of p value which is actually very easy for uh, many people. Mainly I follow this interpretation of p value. Okay, so now p value is actually a area, guys. Okay, because both of these when you see here, what is alpha we are saying as 0.05 or 5%, but what graphically what did we consider, guys? Did we consider it as area or not? Agree? So alpha is an area. Guys, are you there with me?
It's Santosh.
Right, so alpha is an area. Okay, main from the graph perspective, here also and here also, when we say alpha, so we are considering it as area. Fine, so in a similar manner, in the similar manners, p value is also an area. Okay, p value is also an area. So here okay, assuming this as normal distribution. Okay, so over here you will have, let's say, mu equals 0 if it's a normal distribution. Fine, so this area, so how we'll get this area, we'll see. Okay, but whatever this area, right, so this area is p value. Okay, similar to alpha, but there is a quite difference. Okay, so this is alpha. Okay, so the statement is probability of null hypothesis being true is a p value. Okay, now based upon this, how can we accept or reject null hypothesis is important. Okay, so we'll try to understand that. Okay, see here, guys, because here one more thing is, we don't need to calculate any critical value, because the critical value approach is different. See, rejection, in this rejection region, you will have critical value, you will have test statistics, etc. Then you will find out the rejection region. But in p value, you don't need to calculate the critical value, or you don't need any significance value. Okay, you don't need any alpha. Okay, so here how you will calculate over here is, see, we'll see first how you we will see how you can use the values of p, okay, to accept or reject the null hypothesis. Fine, and later we will see how to calculate, okay, how to calculate the p value. Okay, guys,
Yeah, Sandesh.
Yeah, are you there with me, guys? See, we not start the p-value yet, so this is just the basics of p-value. So once we discuss few things, it will be clear. Don't worry. Okay. See, guys, here, first of all, fundamentally, just remember, whenever you are getting confused, just come back to this one single line called as p-value is the probability of null hypothesis being true. Okay. Then again, you can rebuild from that one single statement. Okay. See, if at all you are having very small p-values, okay, if at all you are having very small p-values, okay, so in this scenario, actually I want these two graphs side by side. Okay, so can I erase this part, guys? Can I erase this part, because I want to explain you both the graph and okay, let me erase this. That's fine, because it's just saying that there will be two approaches. One is p-value and another thing is this one. Okay, so because once you if you understand the p-value from the graph perspective also, then only it will stay in your mind as per me. Okay, so fine, let me do one thing. Okay, perfect. Okay, perfect. So see, guys. Okay, awesome. So see, guys. First, oh, sorry. Yeah. So primarily, what is a p-value? Probability of null hypothesis being true. Okay. So now here, if p-value is less than 0.01, okay, p-value is less than 0.01. So what does that mean? So when p is the probability of, okay, null hypothesis being true. Okay. Now in this scenario, if p is less than 0.01, that means what? Just 1%. Okay. So in this scenario, in the first scenario, okay, p is just 0.01. That means 1%. That means what? What does p-value is saying? P-value is the probability of null hypothesis being true. Okay. And if this p-value is very small, that means only in this scenario, there is only 1% of probability for null hypothesis being true. Getting? That means so much, almost 99% of the probability against null hypothesis. Okay. Very strong evidence against null hypothesis. Fine. So if my words are confusing, just let me know. Okay, we'll go. We'll repeat it. Don't worry. Okay. See, we just from this statement we'll try to build. What is p-value? Nothing. It is probability of null hypothesis being true. Now here, if the p-values are very small, that means only 1%. What is this 1%? This 1% is probability of null hypothesis being true. That means there is only 1% of chance from that hypothesis testing, whatever we have done, there is only 1% of the chance for the null hypothesis being true. That means what? 99% of the chance null hypothesis is false. Agree? That means what? We are having strong evidence. Against null hypothesis, because 99% of the time this is false. That means we are having strong evidence against null hypothesis. Okay. In this case, what can we do? Should we reject or should we accept?
Reject. Mostly reject.
Reject. So here we are going to reject. Reject what? Reject null hypothesis. Getting guys? 1% of the 1% chance, 1% probability means we are having only very less, just 1% of the time the null hypothesis can be true. Most of the time it can be false. That means very, very strong evidence against, not for, against null hypothesis. Okay. So obviously when we don't have much evidence to support null hypothesis, so we cannot accept it. So we are going to reject it. Okay. So now in second scenario, okay. Okay. So in second scenario, small p-values. Okay. That means what? If p-value is between, okay, that means what? If p-value is between 1 to 5%. Okay. If p-value is between 1 to 5%, so what does this mean? This means, okay, indicate moderate evidence against null evidence. Earlier, what this p-value is 0.01 indicates strong evidence against null hypothesis, suggesting that the observed evidence is unlikely to have occurred by chance alone. Okay, so that means we're having strong evidence against. If it is 1 to 5, here also we have evidence, but not very strong. It's a moderate evidence against null hypothesis. Okay, so in 1 to 5%, so the probability, this is the probability of null hypothesis being true, 5%, but still we are having evidence against null hypothesis. Okay, against null hypothesis. So here also we can reject null hypothesis. Okay, here also we reject null hypothesis. Okay, and in third scenario, between 5 to 10%. Okay, between 5 to 10%. Okay, so here you have mild evidence. Okay, very small evidence. Okay, and in fourth scenario, okay, if greater than 10%, we'll consider it as no evidence. Okay, no evidence. Sorry. Okay, no evidence. So here we need to accept it. See, here also we can reject it. Okay, we can reject it, but I'll tell you the general thing what we usually do. You remember we generally take alpha equal to 5%. So here also, generally p-value, okay. So this particular value, okay, this 2 is the main thing. Okay, so usually if p-value is less than 0.05, okay, so usually if the p-value is less than 0.05, okay, if p is less than 0.05, reject, null. Okay, focus guys, reject, null, else accept, null. Okay, are these points clear, guys?
Yeah, Santosh.
Yes.
Okay, see, we'll try to understand it more. Fine. So why we are saying 0.05? Okay, why we are saying 0.05? Because usually we take alpha as 0.05. Okay, usually we take this as alpha. Okay, this is alpha. So actually what happens, you know, we can, it is like if p value is less than alpha, reject. This is the actual value. Okay, reject, null. I'll write this. Okay, if p value is greater than alpha, accept. Getting this? So why did I say usually this is the scenario? Because usually we take alpha as 0.05. You remember? So that's why alpha by 2 will become 0.025. Okay, in two tail test. Otherwise, usually it will be just 5%. Okay, in this scenario also, if you see alpha is 5%. Okay, the significance value. And what is alpha? What is alpha? Alpha is just the probability of rejecting true null hypothesis. That means committing type 1 error. Okay, committing type 1 error. You remember guys, type 1 error is that, right? Type 1 error is what? Rejecting a true null hypothesis, and it's also called as alpha. Okay, it's also called as significance level, right? So yesterday we have written significance level is alpha, everything is this type 1 error. So that type 1 error, we usually take it as 5%. Okay, so if you take it as 5%, that means 0.05, fine. Then if p value is less than alpha, that means 0.05, you'll reject. But if you want to take, if you feel that alpha is more, that means the probability, what is again alpha? Alpha is just the probability of rejecting true null hypothesis. It's an error. If you feel there is chances of more error, okay, then you will take bigger alpha. That means you will take, instead of 5%, 10% you will take. So in that case, again, if p value is less than 10%, reject. If p value is greater than 10%, accept. Okay, agree? This is just
greater than or equal to Santosh, like p greater than or equal to alpha, or p greater
Yeah.
than alpha.
Yes, greater than or equal to, you can take. Good point. So if p is less than alpha, reject. Okay, so based upon your alpha, what is your significance level? You can make a call of this value. Okay, this is fine, but the interpretation of p-value is actually from the areas, guys. Okay, see, that is interesting. Actually, you know, p-value is the area, whatever you are seeing over here, this region. Okay, so when you are here you will have the mean. Okay, here you will have the mean. Fine. So the way how you can remember or how you can understand over here is, when you are having less p-values, we will see this again. Okay, so we will consider one case is 0.01. Okay, that means what? Having 1% of probability for the null hypothesis to be true. That means what? This is very, very small. Okay, so see guys, if p-value is 0.01, that means 1%. That means this is very small. It will be, I think, only this much. That means what? This is moving away from the mean. Away from the mean. Agree? That is moving away from the mean. So in that case, we can reject the null hypothesis. Okay. So what does null hypothesis will say, guys? Everything is equal to mean. You remember null hypothesis will say the value after the testing and before the testing is also same. That means it is the same mean. I'm just trying to give an interpretation. Okay, see here, null hypothesis will say it is the mean is equal to 50. That means before and after the testing is also it is the same as 50. Okay, so here also company, yeah, here also it is 50, right? It will always equal to the same value. Fine. So the way how you can interpret it is, so if you're having a mean over here, so 0 or any value, or if it is normal distribution, some value, if it is standard normal distribution, it will be 0. Okay. So the way you can understand here is, if we are having a small p-value, that means you are having a small area. When you will have small area, when you move away from null hypothesis. Okay. When you move away from null hypothesis, obviously you should reject null hypothesis. Okay, so I will repeat. When you're having small values of p, that means there are different ways how you can understand. Simply, if you want to go by the statement, just what is the statement? This statement, probability of null hypothesis being true is p-value. When I'm having p-value is very small value, that means obviously I have very, very small probability for the null hypothesis of being true. If something is having very small probability of true, why I will accept it? If I say, hey, the probability of me getting first rank in my class is 0.2%, will you believe me? Obviously no, because the probability what I'm giving is extremely less, 0.2. It doesn't affect at all, right? Almost it is false. So similarly here also, if the probability of something is being true is just 1%, out of 100%, only 1% it is true, 99% of the time it is false. So obviously I cannot accept it. I will reject it. Fine, I'm going to reject it. That is one way which you can directly understand from the statement. Okay. Is the statement part clear, guys?
Yeah, Santosh.
So that is one thing. Same thing, because we as a humans, we understand pictures in better way than words or statements. But same thing, you can also understand it as p-value is also the area. Okay, so when you're having only 1%, that means it will be small area. A small area will always be moving away from the mean. Okay, when something and null hypothesis, we usually say null hypothesis will stay here. Null hypothesis will stay here. Okay, so a p-value, a small p-value will obviously move away from null hypothesis. So we will reject null hypothesis. Clear?
Yes.
Okay, fine. Now, even if it was 0.05 also, fine. So even if it is 0.05 also, if it is less than 0.05, okay. For example, your confidence level, okay, your confidence level, sorry, your alpha value is somewhere over here, 0.05, okay. So if it is less than that, okay, if it is just less than that, so obviously you will have something over here. Less than that means what? Area is less. If p-value is less, area is less. Simple. Okay. So if p-value is more, area, the whatever the area you are covering is more. Okay. So p-value is, I'm just saying, if it is less than or equal to 0.05 and it is greater than 0.1. Okay. So that means what? If it is just less than or equal to this 0.05, okay, this area, in this area also, you can reject the null hypothesis, because this small area definitely you are going to reject, but here also you are going to reject. Okay, based upon your alpha value. Okay, but if it is greater than alpha, okay, so if it is greater than alpha, that means you are moving towards the null. You are moving towards the null. So in this case, you need to accept it. Okay, but in this case, you need to reject it. Okay, guys. So just remember this line. Okay, and the standard values are 0.05. Okay, and when you speak about the p-value, okay, just visualize this diagram in your mind, and this small region, okay, here you will have 0.05, okay, because your confidence, sorry, the alpha value is 0.05. Okay, from here you start building p-value. If it is a small p-value, obviously this area will become smaller and smaller. Okay, so as a p-value is decreasing, okay, as per the statement, anyhow, it's a probability of null hypothesis being true. Okay, if it is decreasing, probability is decreasing. So we are moving away from null hypothesis. Null hypothesis is becoming more false, false, and false. Okay, that is also true. But area-wise, you can understand and you know you can answer faster. So when I'm saying small p-value, that means what? This area is becoming smaller. Okay, so it is becoming smaller and smaller and smaller. Okay, that means you are moving away, further away from the null hypothesis. Okay, a very, very small p-value will strongly reject the null hypothesis. Okay, a very, very small value will strongly reject the null hypothesis. If it is p-value is increasing, that means what? Probability of null hypothesis being true is increasing. So you need to start accepting null hypothesis. Okay, guys, are you getting? From the area perspective?
Yes, sir.
But Santosh, like I have small doubt, confusion.
Yes.
For example, if it is 10%, let's say, I mean, instead of 0.05,
Mhm.
so if it is p-value is greater than, so rejection area will be more, right? Here, like green color part will comes to near to mean, I mean, left side. So in that case,
No, this is not the rejection region. This is the
okay,
p-value.
okay,
P-value
okay,
is
got it,
what?
got it.
P-value is the probability of null hypothesis being true. So if you are increasing more, so indirectly you are saying there is no more probability for the null hypothesis being true and true. So you're
Yes, yes,
actually
okay,
accepting, in other words, it's an acceptance region.
okay, okay, got it. Yeah,
Okay.
that's what. Yeah.
But that's a good question. Since you asked here, so p-value in this critical scenario, okay, in the critical region scenario, okay, when you are calculating the z statistic and based upon the alpha value in the rejection, that will be the rejection region. Okay, that will be the rejection.
Here it is rejection region.
Here it is rejection region. Okay, so if the
That is
value is falling over
acceptance.
here, it's rejection region. Okay, and I would say, yeah, but here also, if you, yeah, okay, so if the, yeah, so if the alpha is over here, so the everything over this side to the right side or left side is rejection rate. Okay, but here p-value itself is this is the area is symbolizing what? It is indicating the probability for the null hypothesis being true. So if the area is increasing, so let's say area is this much, all this area, that means what? There is so much of the probability for the null hypothesis being true. That means you should accept the null hypothesis. So it's, in other words, it's like a acceptance region.
Okay, Sandesh, yeah, got it.
Okay. So clear, guys? So, and also, yeah, just to mention, this will again solve the problem which we had with the rejection region. Okay, so here, because there is some value, okay, see, a small p value will have larger evidence against null hypothesis. Do you agree with me with this point? Because the area, in simple words, guys, if this is creating confusion, simple words you can understand it as small p value strongly reject null hypothesis. Why small p value? It means small probability. Small probability means small area. If the area is very small, we are moving away from the null hypothesis. So just reject the null hypothesis. Okay. If the area is big, then it's not that strong. Okay, mild evidence. So here, that means what? In earlier example, if you try to correlate, see guys, let's say this is in the rejection region part. Okay, in the rejection region part. So if you see here, so we had something called as 1.65. Okay, and I have just told you that if 3.28 is falling over here, okay, you are rejecting. But let's say if you extend this and if you have 30 over here, still you are going to reject. Okay, so here if you have something called as 1.7, you are going to reject. Okay, so you are rejecting 1.7 and also 3.8 and also 30. Okay, but what is the strength of the rejection? That is also important, right? We have discussed. So over here, if you see, now we are getting the area. Area is something which you can quantify. Okay, so here if you have a value 1.7, okay, here if you have a value 1.7, agree? So it will have large area, agree? 1.7 means it will have all this area, this complete area. Yes, guys?
Yes.
Now, if it is just over here, that means, let me, as an example, let me take it as 3. Okay. So if it is 3, only small area. Okay. And if it is still, for example, I'll just take it 10. Okay. It is still smaller area. Okay. So let me erase this one. Okay. So for 10, it is very small area. Okay. So the first one is for 1.7. This is for 3. This is for 10. Okay. Now, instead of just saying I'll reject 1.73 and 10 equally, here you can directly say, if the area is very, very small, that means what? High rejection or low rejection?
Very small area, high rejection.
Okay, here you will strongly reject. Okay, you will strongly reject null hypothesis. Why? Area is small, so it is moving away from the null hypothesis. So the probability is very small. Okay, here you will the degree. Okay, so moderate
Moderately.
reject. Okay, here you will reject, but with a lower confidence. Fine. Obviously, you can say what is the strength of your rejection. Instead of just saying it is falling in the critical region, it is falling in the rejection region, I will reject. Here, based upon the value of the area, you can also say what is the strength of your rejection. Okay. And if you're just at this point, okay, if you're just at this point, okay, your strength will be very, very less, because just if you step this side, you should accept null. Okay. If you step that side, you are rejecting. If you are on that line, okay, and if your strength is very, very low, fine, then you can also decide whether you want to, with that small confidence, if you want to reject or not reject, that is your call. At least you are getting some deciding factor. Agree? But in earlier case, we don't have that. If it is following the rejection region, just reject. Okay. But here you have also something area concept. Okay. From that, you can also get your strength of the rejection. Okay. Is this clear, guys? Everybody?
Yes, Santosh.
Any doubts? Any clarifications? Sirisha, you getting the concept?
Yes, sir.
Okay. If my p-value is 0.02, what I should do, Sirisha? Should I accept or reject?
Reject. Reject the null hypothesis.
Okay. And accept what?
If it is greater than 0.05, we want to accept.
Okay. Fine. Cool. So this is regarding the p-value, and we'll try to actually look at this problem. Okay, we'll try to look at this problem using the p-value. Okay, so let me take that. Okay, and let me put it over here. Okay, now this same problem. Hey guys, are you going to college today?
Yes, sir.
Oh, what's your time? How much more time do we have? Do you have 10 minutes?
Okay, sir.
Meghana?
Yes, sir.
Okay. No, I'll just yesterday we have solved these two examples, like company example and the lace example using the critical region, right? So just I will just show you quickly how you can use a p-value and how simple it is. Okay, fine. So just to give a recap in the rejection region, so these are the parameters. What was the concept, guys? What was the question? The company was saying earlier it was the whole population productivity was 50 units. After that they gave some training program, okay, for random of 30 samples, and then whether 30 samples was having productivity of 53. Okay, just for sample. Okay, with this sample he is asking whether the training has have any positive impact on the overall employees or not. Okay, that was an example. And using our rejection region approach, what we have done, we have considered, and finally what did we do, guys? Did we reject or accept the null hypothesis?
We are rejecting, sir, in this scenario.
Correct. So we are rejecting because 3.28 test statistics is falling over here. So we are rejecting the null hypothesis. Okay. So and accepting alternate. Okay. That means what? Yes, actually it has provided some positive impact, the training on the overall population. Fine. So with the same scenario, what we are going to do over here is, okay. So in this scenario, see. Okay, so over here, again, same thing, you need to calculate the Z statistic. Okay, so you need to calculate the Z statistics. Okay, these steps will be almost similar. So, but instead of rejection region, you will use a p-value. Okay, so you need to calculate the null hypothesis, alternate hypothesis, 5% we are taking for the alpha, choose the type of test, etc. Okay, that I'm not repeating because here itself you can see these are the values. Okay, these are the values. Okay, and the Z statistic is this one. Okay, you got some 3.28. Okay, so I'll consider those values. Okay, so in this scenario, so you have test statistic. What is our test statistic? Test statistic is see, if I just
3.2.
yeah, how did we get the Z statistic, which is also called test statistic, is x bar minus mu by rho by square root of n. Okay, so x bar is a sample size which is 53. Okay, minus 50 is the population parameter which is 50. Okay, and rho is a standard deviation. What did they give? The standard deviation of 5. Okay, 5. Okay, and square root of 30. Okay, so this you do, you will get something around 3.28. Okay, test statistic. Now that means what? This one is this value. Okay, somewhere here it is 3.28. Agree, guys? We have plotted the same thing, right? So 3.28 was coming somewhere over there. Okay, 3.28 was coming somewhere over here. Agree? Now we don't have, see, now we don't have this 1.65. That 1.65 will come from the rejection region or critical value. So that we are not going to do. That is different approach. Rejection region is different approach. We don't want this 1.65 now. Okay. We just want this test statistic, and from that we'll calculate the p-value. Okay. So now, so I don't know whether where 3.28 will come. It might come here, it might come here, somewhere it will come, but I'm just as an example, we are taking it over here. Okay. And to the right side of it, okay, we will have a region. Okay. So now we need to calculate what is this area. Okay. So what is this area? That means what? This overall area is how much? What is the overall area? Can someone say?
1.
1. Okay. Total area is 1. Now, if from the table, if I check for 3.28, what area I will get, guys? This area I will get. From class 1, we are seeing this concept
Yes.
that whenever
From-
whatever the value you take, it will take less than or that value.
Yes.
Cumulative probability concept. Okay. So from the table, okay. So from the table, if you take the area of, okay, so total area is 1, okay, and this area shaded region is
1
area
minus.
of, no, shaded region is area of 3.28.
Okay. I mean, green color shade.
Yeah, orange
Yes.
orange shaded. Okay, so what will be the green shaded, guys? This value will be our p-value. Okay, so because this is our test statistic, and right side of this, so where the area, whatever you have, right, so that will be our p-value. Okay,
Yes.
so the p-value will be what? 1 minus area of at 3.28. Okay, so this is overall thing is 1. From that we are removing this orange shade is what? Orange shade area we will get when you calculate the what is the area at this particular 3.28 from the Z table. Okay, so go to Z table and how much area you want, guys? At 3.28, right? At 3.28 value. Okay, 3.2. Fine, 3.2 is over here. See, this is a value. This is not the area. This is a value. At this value, how much area you want? Okay. So 3.2 is over here, and where is 8? 8 is over here, last but one. Okay, over here, 3.2. 0.9995. Do you agree?
Yes. Yes.
0.9995. Okay, so 0.9995 will be this area, right? So this is 0.9995. Can someone tell me how much this will be?
0.0005.
Okay, Sirisha is saying 0.0005. Okay, so this area, so obviously now it means that, okay, so yeah, so this area is 0.9995. Okay, and this small, see, just as a diagram, it is actually showing like this, but actually 3.28 is coming over here. 0.0005 means how much, guys? Okay, so actually if I draw, okay, before that I have drawn like this because I don't know where this 3.28, but actually now what happens, guys? This 3.28 is okay, see, the actual diagram will be, so if you consider this as some distribution, okay, so the whole thing will be this one. Okay, what is 0.00005? Almost 0. Agree? Are you getting?
Yeah, Santosh. It's
Okay.
negligible.
So it is whatever the small part you are seeing here, right? Let me take it as just a small part. Okay, so this is actually the 3.28. 3.28 is falling over here. 3.28. 3.28. Okay, 3.28. That means it's covering almost 0. See, before this to the left side, it's covering complete area, almost one it is covering. Just 0.005 area is this much. Okay, so somewhere here you will have your null hypothesis. Okay, so so now what is the value of p-value 0.00005? Okay, from where did we get it? From the test statistic, wherever the test statistic is falling. Okay, so you will see how much area to the right of it is having. Okay, the p-value. Fine. So now if you see the null hypothesis is over here, okay, and the p-value is over here. So can you tell me what we need to do in this case? Accept or reject?
Reject the null hypothesis.
Why?
It is less
Justification
than,
also.
I mean,
The p-value.
p-value is less than 0.5.
The
Okay.
area of p-value is less.
Area of p-value
Okay, okay. First thing is, on what points you are saying? First thing is, p-value is
less than
okay.
0.5.
Is it 0.5 or 0.05? 0.05.
0.05. Yeah, 0.05.
Okay. 0.05. Okay. Based upon that, we are rejecting it. Okay, that's perfect. Because this 0.005 is less than 0.05. Okay. And second thing is the area is very small.
Very small.
Okay, too small. Okay. And third thing is it is moving away. Obviously, it's the same thing, but when the area is too small, it is moving away from the null hypothesis. Okay, very much far. Too far from null hypothesis. Okay. So with this scenario, from this scenario, you can say we are going to what? We are going to reject this guy. Reject null hypothesis. Okay. And accept the alternate. And what is this null? So if I just go back, over here in this scenario also, what we have done, we have rejected the null hypothesis and we have accepted the alternate hypothesis. Okay, which means that,
So,
yeah,
which means we are saying as per the company, I mean, they have given one statement. So we are saying, yeah, yours is wrong. Something else is correct. That's
no.
no.
See, man, company did not give any statement. Okay, you are saying about the sample. No, see, company did not give any statement. Company is asking us to check whether the productivity has increased or not. This null hypothesis and alternate are
Okay.
our hypothesis. Yesterday's scenario is different. In the type 1 error, in case after our testing and everything is done, in case if company calculates the overall population and he will say, if it gives us the measurement that if the actual productivity is increased across all the employees, then that is a different matter. We will come to know whether whatever the null hypothesis we are considering, whether it is true or false, we don't know. That time we will be knowing. But most of the time, we will not have the population values. Agree?
Okay.
So whatever the null hypothesis and alternate hypothesis we are taking, we will continue on that. We will base all our arguments on top of that, and we will do our testing and we will give the results. Okay, that is the only thing we can do, right? From the given data only, we need to frame our null and alternate, and we will do. Okay, so these are not statements; these are just hypotheses. That's why it's called hypothesis. Is what it's just a guess. It's my statement. It's a theorem. Okay. So theorem can be true, theorem could be false. Okay, these are just statements. Okay, the company is also not giving any statement or facts. It is only telling I took a sample. Samples productivity is 53. I don't know about the whole population. You tell me what is the overall population effect, whether it has increased significantly or not. That is the company is asking us a question. On that we are framing this hypothesis. After from the testing, either by rejection region also we are rejecting, or from the p-value also we are rejecting. Now we are coming. Based on our testing, based on our calculation, we are confident that we can reject this and we can accept this. Okay, that is what we are saying. But see, Karthik, but this is based on our calculation. But in case if some anti-person, okay, so who want to prove you wrong, if we take some time and goes to this 1,000 people employees in the company, and if we calculate the productivity and if we check the mean, do the average, If we get some value, okay, if we get some value that it is actually the actual productivity is not increasing, it is 50, it is 50 only. So the fundamental hypothesis, whatever we are considered, this is we considered, right? So mean equal to 50, that is true or false. Okay, if at all null hypothesis, this guy is saying 50, right? So for example, he has calculated the null hypothesis, okay, and he has considered that the null hypothesis is actually not equal to 50, it is greater than 50 or less than 50, something he has found out. Okay, after the test, after the training, see, I'm coming again. What is the null hypothesis we are framing over here? I am framing that even after the training program, there is no effect at all on the employees. The mean is still 50. That is null hypothesis saying. After the training, these both are after the training only. The company is asking if the new training is having an effect. I don't know whether it will have effect or not. So that's why what I will say, I will take one null and I will say, hey, assume that even after the training also, the mean is same 50. But alternate will say, hey, no, after training, it is greater than 50. Is that clear?
Yeah.
Okay, fine. So these are our statements, and we have done, and from this we have rejected this, we have accepted this. Okay, so fundamentally what we have considered that null hypothesis as there is no effect on the training is not having any effect. That is our null hypothesis. Okay, but if some person, okay, so he calculates and he checks, no, actually the training is having, okay, after the, yeah, so correct, yeah, correct. I think earlier I said it a different way. Okay, so after the training, okay, after the training, if the productivity, if it is still 50, okay,
Yes. Okay.
after the training, if the productivity is still 50, then what does it mean, guys? Because you are saying after the training program, you are saying it is greater than
Yes,
50, but
yes.
he has considered it is actually
50.
50. Okay, so in that case, what has happened? Whatever
will
the
be-
null you have considered, that is actually true,
Yes.
right?
Yes.
But you have rejected that
Yes. That
and
comes under
accepted
type 1, right?
alternate.
I mean, that comes under type 1, right? If in case.
Yeah, type 1, right? Type 1, right? So if
Yeah.
at all you have the, after 1 month, if you have the whole people's data and if you calculate, if it is still 50, but you are saying wrongly as greater than 50, but instead of actually what you might have done, you should have accepted this. Agree? You should have accepted
Yes.
this because actually it is only 50. From your test, I don't know why you are getting greater than 50. Okay, due to you need to check that. Okay, if that is a scenario. But in the scenario, as per the reality, if you want to match with the reality, it is still 50. Okay.
Yes.
So it is still equal to 50. So, but you have rejected this true null hypothesis. You have rejected true null hypothesis and accepting the
Yes.
false alternate hypothesis. In that case, it is a type 1 error. Okay.
Yes.
That when you will know, when you have the population parameters, that is a different
Yes.
scenario. Okay.
Yes.
Now let's not get into that. Okay. Coming back, if let's say you don't know whether this is a true or false. Usually we will frame our null hypothesis and we'll frame our alternate and we will carry our test. Okay. So in that scenario, you have considered this as null, this is alternate. Okay. So based upon your rejection region, you are canceling this and approving this, and based upon our p-value region also, clearly our area is too small where we are going to reject null hypothesis. So obviously from whatever we have framed, we are again rejecting this as per the p-value and we are accepting this. We are saying, hey, I'm going to accept this. That means the productivity has actually increased is what is my statement till now based upon my test. Do you agree?
Yeah, Santosh.
Okay. So from these assumptions, from my statements, I am true. Till today, tomorrow also I will true. Okay. I did not commit any type 1, type 2 error. I don't know. Okay. Nobody knows. Till as long as we don't have the overall this picture, nobody knows. Agree? I'm true. Till the day, in case if the company, actual company, okay, he will come and tell us, hey, actually, I gave the same problem to another team also. The same project I gave some other survey person also. He surveyed actually the whole 1,000 employees, and he actually said that, sir, there is no increase in productivity. It is still 50. Then comes the situation of type 1, type 2 error, because you are comparing with the actual scenario. The overall true population values, we are saying it is still 50, but we are saying it is greater than 50. Then there is a mismatch. Then type 1, type 2 error will come into picture. But as long as you are not aware of this picture, okay, so you will go by your assumptions. This is your hypothesis testing. And from these assumptions, you will consider one of the approach, rejection region or p-value. You will get some evidence. Based upon this evidence, you can tell which one can reject, which one you can accept.
Yeah, Santosh, got it. It's completely based on sample itself, not
Right.
original population.
Yes. Because if it is based on the original population, then you don't need all this. Because if you have all the values of original population,
Yes.
you know, after the
Directly we
training also,
can-
you know, see,
Yes.
before the training, he's saying the average productivity with the overall population is 50 years. He's saying, see, I will tell you in simple words. Before training, he's saying the average productivity is 50. Okay. If you also say after training, the average production is 53, what does that mean? Whether it is increased or decreased?
Increased.
Increased. So he's only saying the overall my employees, 1,000 employees productivity before training is 50, after training is 53. So then there is no need of us to do all this test. So, but what he's saying, before the training, the overall population, the complete 1,000 employees productivity is 50. But after the training, after implementing, only sample he's saying.
Yes, sample of 30
Okay,
employees. is
sample.
same. Yes.
From that sample only, we need to calculate and give a value for the overall population. Okay, he's giving a sample, but asking for the overall population, because he's not asking for sample, because for sample, he's only saying, I took a sample and that sample productivity is increased by 53. He's saying, okay, but based upon the sample, tell me whether the new training has increased overall for the population.
Yeah.
Getting
Yes.
others? Any confusion, guys? Anywhere you got confused, Sirisha, Meghana?
No, sure.
Okay, fine. So to put it simply, not going into this picture. So there are two ways. So from rejection region also you have rejected, and from the p-value also clearly you have rejected. So as of now, we are very strongly saying that yes, the new program has had some positive impact. Okay, fine. So now coming to the second example, quickly. So I'll also show you. So in this, see, in this way, for example, also, quickly I'll show you. See, in this way, for example, also, what does he was saying? He was saying, actually the 50 grams. What was his statement, guys? I forgot. So the wafer contains an average of 50. He decided to test it, and he collected a sample of 40. Okay, and that 40 is having a sample of 49. Okay, see here, true population is 50, standard deviation is 40. He has took a sample of 40, and that's this 40 sample mean is 49. So he's asking whether the overall population's value is differing from 50 or not. Okay, it is a two-tailed test. Getting, guys? This is a two-tailed test, because he's not asking whether it is greater than 50 or less than 50. Just in before scenario, he's asking whether it is just increased. That means you will take only greater than 50. But here he's asking just test whether it is equal to or not 50, whether it is equal or not to 50. Okay, so you need to calculate two-tailed test. Fine. So in the rejection region also we have done the same thing, but here in the alpha we have divided into two, one side 0.25, 0.25, and then we have calculated this area. Okay, and then we said this minus 1.58 is falling over here. Okay, so that's why we did not reject it, we have accepted it. Agree? So, but similarly over here, what we are going to do, so let's, if I take a, yeah, so if I take the graph over here. Okay, so if you take the graph over here, so since it is a two-tailed test, okay, it is a two-tailed test. Okay, that means you will have some values to this side, you also have values from this side. Okay. Okay. Fine. So now see guys, in this scenario, you will have two areas. Okay. So what is our Z statistic, guys? I'm not trying to calculate it again. So here, if you calculate the Z statistic, it is somewhere around 1.26 or what? Z statistic is 1.58. Okay, guys.
Yes,
Do
Santosh.
you agree? So Z statistic is 1.58. Okay. So you will have it in two ways. Okay. So and this side you will have, yeah. So over here you will have 1 point. How much it was?
58.
Okay, 58, and here it will be plus 1.58. Okay. So the p-value is both these areas. Okay. So here the p-value is, earlier the p-value is only this much area. Okay, from the wherever the Z static is covering, but here it is you need to calculate not equal to 50. Here you need to just calculate not equal to 50. So it could be less than or greater than. Okay, here you will have the mean. So p-value will be, this is area 1 and this is area 2. Okay, so the p-value will be area 1 plus area 2. Okay, so now what is this area? This area is going to be, for example, if you try to calculate only this area. Okay, so if you calculate only this much area, so minus 1.58. Okay, so where you are having minus 1.58, we'll try to sorry, yeah, we'll try to see minus 1.5. Okay, and 0.8. Okay, fine. This is 0.05. Getting guys, minus 1.5 and 0.8. Minus 0.05. Agree?
Yes, Santosh.
This area is 0.05. And this area is again same thing. This area will also be
Same.
0.05.
Yes.
Okay.
0.
So this will be 2 times 0.05. How much it will be?
Zero 0.025. 0025.
0.10.
Right. So 0.05 into 2 is 0.1. Okay, it will be 0.1. Okay. So now p-value is 0.1. Okay. And usually our alpha is 0.05. Okay. So we have considered this scenario. We have considered if p-value is less than alpha, reject. But here, is the p-value is less than alpha or greater than alpha? Which one is greater, 0.1 or 0.05?
0.1.
0.1.
Which one greater?
0.1, sir.
Oh, you said that. Okay, I heard it different. Okay, so this is greater. So since p-value is greater than alpha, what can we do? Accept or reject?
Accept.
Accept.
Correct. So if p-value is greater than alpha, we are going to accept the null hypothesis. Okay. So here also we are having more probability. That means 10% of the probability for null hypothesis being true. So we are going to accept it, and also the area is bit more. So if you add this side area, that side area. So for example, just a simplicity, if you add this one also to here, so it will be somewhere over here. Okay, somewhere over here. So if you consider both, so half of also you will consider also, it is the area is more. So you are moving towards null hypothesis. So in this case, you need to accept the null hypothesis. Okay, so since in the same scenario also, in the previous example also, if you see our critical region in the our Z statistic is not falling in the critical region. Okay, it is moving away from the critical region. So you need to accept the null hypothesis. That means whatever the wafers company is claiming that 50 grams, that is actually true. Okay, similarly here also you need to come, and what you need to do, you need to just accept Okay, you need to accept the null hypothesis. Okay, guys.
Yeah, Santosh, clear.
Okay, so this is how you can interpret the values of P, guys. Okay, it's a simple approach. Fine. So instead of calculating all that critical values, etc. Okay, so just you need to calculate the Z statistic. Okay, just how you're doing Z statistic. Once you have the Z statistic, that's all. So anyhow, you will calculate, you will have some alpha value. Okay, based upon that alpha value, you can calculate this area. Okay, so just calculate this area from the Z table directly. It is available. Okay, if it is too small, see this value is 3.28, but this area is 0.0005. Okay, don't get confused. 0.00005. Okay, very small area, moving away from the null hypothesis, small area, small probability, reject. But here, bigger area, moving towards null hypothesis. Okay, you cannot reject, so you need to accept it. Okay, fine. So I would say that's regarding the p-value. Okay, and we are going to see this p-value is independent of test. Okay, you can use it to Z test, T test, different types of test. Okay, tomorrow we are going to see different examples how well you can use this T test. Okay, if possible, we'll have a class in the evening. Okay, or else we will see it in the next class. Okay, fine, guys, that's all from my end today. So I hope you understood the p-value. If it is a bit confusing, please go through the class once again and make some notes. Okay, and compare both the approaches, and it should be clear, else you can ask me doubt. Okay, fine, guys, thank you so much.